All right, in this video, it's a reteaching of the first unit of the year where we dealt with arithmetic and geometric sequences and series. We're going to break this up a little bit differently than we taught it in the first unit, and it's going to follow the lizard book that's on the shelf, chapters 9, section 2, and 9, section 4, which is strictly arithmetic patterns. So if you remember, arithmetic is just plus 2, plus 2, plus 2, adding the same thing like this example is adding 2 every time. And you'll find, I think, the second time you hear this lesson that more things start to make sense than they did before because you've heard it multiple times now reviewing for benchmarks, but even more so you're familiar with the symbols. And that was the biggest hurdle to this unit was all of the symbols and what do they mean and how do you use them and whatnot. So I'm going to focus the notes on showing how to use the formulas, which are on the yellow sheet. This is the arithmetic sequence formula, and the arithmetic series formula is S sub n equals n over 2 times parentheses a sub 1 plus a sub n, exclusively for this page of notes. Again, we want to avoid the formulas when possible, but sometimes it's just not possible. So I'm going to show formulas and get you reacquainted with those if you happen to have forgotten the formulas. Number one, it starts with writing an expression to find the nth term of the pattern 5, 7, 9, 1. Remember, n equals 1, n equals 2, n equals 3, n equals 4 goes with each term. And it's a pattern that's arithmetic, and it's a sequence. So we're going to use the sequence formula. The a sub n term is the first term, a sub 1, so 5, plus n minus 1 times d, which is the thing you're adding each time. So you're adding 2, so you multiply that n minus 1 times 2. So you distribute your 2 and combine like terms. You get 5 plus 2n minus 2, or just 3 plus 2n. I like to write that as 2n plus 3, which it doesn't really matter which way, but a sub n equals 2n plus 3. That's a formula for any nth term. I'm going to now use the arithmetic sequence formula to find the 35th term. So again, same formula, a sub n, a sub 35 equals first term 5 plus n minus 1, well the 35 is the n, times d, which is 2. So that's 5 plus 34 times 2. 5 plus 68, the answer is 73. Yes, if those of you who are watching this are thinking, why didn't you just, and could you have used the formula? Yes, I could have used the formula I just wrote in number 1, 2 times 35 plus 3, and I would have got 73 as well. But if you don't write the formula first, you won't have the formula first. So I wanted to show you how you could use the original sequence formula on your yellow sheet. And then one more problem that deals with the sequence formula, question number 5. So I'm skipping 3 and 4. Question number 5, again, is just a list, a sequence, and A1 is 25 and A4 is 64. Your task is to find the 2 that are missing in the middle. If there were 3 missing in the middle, you might remember there's a shortcut of averaging, but when there's 2 missing, you can't use that shortcut. The only thing you can use is the formula highlighted at the top here, the sequence formula. So what we have is 25 is the first term. So 25 goes on the right side of that formula, plus n minus 1 times d. We don't know d. There's no way that we can know information to know d. You got to have 2 terms back to back to figure out d. But we have the information for n and a sub n. The 64, that is the 4th term. So 64, the term goes there, and the n associated with it goes in the formula there. So now that we've got everything filled out, the only missing variable is d. So we can algebraically solve for d. 64 equals 25 plus 4 minus 1, which is 3. D, subtract your 25 and you get 39 equals 3d. Divide by 3 and d is 13. D is the thing you add, so now we can find the missing terms. If we add 13 to 25, you get 38. If you add 13 to 38, you get 51, and if you, just to be safe, add 13 to 51, you get 64. So that's all of the uses we studied using the sequence formula, you know, um, really quickly shown. So you may need to watch it again, may need to rewind it and whatnot. But now let's deal with the series formula, which, if you'll remember, the series formula is used to find sums. So number 3, find the sum of the first 20 terms. So S sub 20, S sub 20, so N is 20. S sub 20 equals 20 divided by 2 times first plus the 20th. Well, the 20th term is, the first term is 5. But the question now is, what is the last term? What is the 20th term? Well, just like question number 2, you can find that 35th term using the original sequence formula or the one that you created in problem 1. You can do that here. The 20th term, A sub 20, equals the first term 5 plus 20 minus 1 times D, which is 2. So 5 plus 19 times 2, 5 plus uh, 5 plus 38, we get 43. Sorry, I was looking over my notes and I was doubting myself there for a second. And the reason I was doubting myself for a second is because in my notes I actually used this formula, 2 times 20 plus 3, which is 40 plus 3, which is also 43. So again, I just said it, but I wasn't thinking. You can get that 43 answer either of the two ways, using the formula you wrote for any term, or using the method we did here, using the original sequence formula that works for any sequence. All right, but then finish it off. This is 20 divided by 2, 10, times 48. Your sum would be 480. Of course, you've got the option of listing the next term after 11 is 13, then 15, then 17, listing all 20 terms and hit plus, 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 plus. And on a test, sure, that's fine. But these notes are being used to teach the formulas themselves. So it's getting kind of messy. So I'm going to erase all the notes so far to deal with question 4 because it's getting kind of messy. Question number 4 says find the sum of the first through the 25th term. So I'm going to plug in a 1 into this formula. 2 times 1 plus 3, 5. Then I'm going to plug in a 2 into the formula. 2 times 2 plus 3. 4 plus 3, 7. Then a 3. 2 times 3 plus 3. 6 plus 3, 9. And I start to notice a pattern. Plus, plus. This is the list of numbers right here that we created. If you'll remember, 2n plus 3 was the expression we wrote right here for a sub n. So things are starting to line up here that, yeah, that's the same formula. It's the same numbers. Okay, I'm just adding up the first 25, just like we added the first 20 in question 3, which means we can shortcut this with the sum formula S sub 25 because we realize it's arithmetic. We can't just automatically use this formula for any sigma. We can use it for any arithmetic sigma, and we're realizing this is arithmetic because we're adding 2 each time. All right, so the formula says n over 2 times first plus last. The first term, we got that one. It's the 5. The last term, the 25th term, would be 2. So dot, 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 2 times 25 plus 3. That'd be 50 plus 3. That'd be 53. So the last term is 53, and you're adding up 25 terms. So again, option 1, you could have just continued listing 5 plus 7, 9 plus 11 plus 13, all the way to 25 terms, or you can use this shortcut. And again, we're focusing on the formula, so we're using the shortcut. 25 divided by 2 is 12 and a half. Multiply that times 58, 5 plus 53, and you get 725. All right, so that's got the notes covered. we've got some practice problems down here at the bottom, a your turn, that you are basically going to do everything we just did with new numbers. And then the homework is listed at the bottom, and the substitute will have your worksheets for those problems. But I'm going to pause the video. I encourage you to pause it as well. I'm going to work through all the questions and just reveal the answers. So if you have discussion, you could talk about the problems amongst yourselves and see what happened here, why is that number there, before you start the homework. But again, pause the video. The next time that I start recording, the video will have all the answers for 6A through C, question 7, and question 8, and you should be ready to start the homework. All right, if you've made it this far, you pause the video and press play again. Obviously, you see the answers now on here. I've tried to color coordinate those answers. If you have any questions, again, about those answers and how those came to be that number, why is that number there, it'll take a little while at looking at them, looking at your work. But I know there are people sitting in the room that can help you figure out why is that number negative 273, for just one as an example. Where did that number negative 273 come from? Well, it came from it being the 100th term. You've got to add 100 terms, then you've got to find the 100th term. So things like that you can talk about amongst yourself, figure out what's going on. If you have questions, mark them. If you can't do a certain section in the homework, mark it. When I come back, I'll kind of help you fill in the blanks. But I would imagine there are people in the room that could help you as well. Don't be afraid to ask, okay? But your homework's here at the bottom, section 9.2 and section 9.4. The worksheets will be passed out if they haven't already. And there are obviously questions that are skipped. You could do more too. There's also the lizard book on the shelf. If you go to chapter 9, section 2, there's plenty more questions there. There's more examples there. They explain their work and show their work, so you might need to look through some of that. But those are all the options you have, and that should be enough for the first day reviewing arithmetic and series. The next video will be geometric. Same thing. There's a formula for both of those for series and sequences. And then the third video will be for non-arithmetic, non-geometric patterns. That's the most difficult one of